All right. So what I just gave you is an introduction to a technique about counting. Okay. But it's a technique that and there's a couple different techniques that we'll use and we'll address here. But it's all purposed for learning about probability. Okay. And I think probability is going to be what we kind of finish the year up with. I think maybe over the next, I think we got like 15 school days maybe, in that ballpark. Correct me if I'm wrong. Right. So, I mean, we got today. So we counting today or not? No. Okay. So then, 3-hour delay tomorrow. We counting tomorrow? No, we don't. Okay. 2-hour delay on Friday. Okay. So let's count that. So, but we got 1 2-hour delay coming up, right? Okay. And then we've got 1 full day Monday of next week, and then we got a 3-hour delay Tuesday. We don't count that day?
Really? Let's not.
Okay, let's not. So then we got 1 2 3 4 5 6 7 8 9 10 11 12, 13, 14, 15 full days. 15 full days. We've got 2 3-hour delay days. And we've got 1, 2, 3, 4, 5 2-hour delay days. Yeah, but they're not 21 full days, right? Okay, so I think we can wrap up. The year talking about probability and different aspects of probability. If we get through it, then maybe we'll move on to something else. But that's kind of where my head is right now with this. When we talk about probability, we need to know something called a sample space, which is the possibility or the total number of possible outcomes that could happen. So if I were to ask you, is it likely for you to play the lottery and win? The answer is no. What if I ask you, what is the probability of you playing the lottery and winning? You need to know how many winning tickets you have, right? Or how many tickets that you do have, okay? And how many total tickets are possible, right? Does that make sense? Okay. So if I ask, what is the probability that you have a winning lottery ticket, or you play the lottery tonight and you win it tomorrow? You would need to know how many numbers there are in the game, right? So I think, I could be wrong here, but I think Ohio, let's just say it goes up to 65 numbers, okay? Goes from 0 to 65. Those are the numbers that can get chosen, okay? And you can repeat numbers, okay? I think. Let's say you can't repeat. It's better if you. For us right now, it's better if you can't repeat it. And let's say that I don't play a lottery, so I don't know all these rules. But let's say that there are 7 numbers you got to match. Okay. How many different 7-number ordered lists can you make from that scenario where you're choosing to fill in 7 spots, you're choosing a number between 0 and 65. Would that be very difficult for us to go down by hand and say, okay, well, 0, 1, 2, 3, 4, 5, 6 will be one winning ticket or one possible ticket? Does that make sense? 1, 2, 3, 4, 5, 6, 7 would be another one. Okay. 2, 3, 4, 5, 6, 7, 8 would be another one, right? But then, 5, 4, 7, 1, 3, 2 would be another one, okay? That list of very, very, very long outcomes would be very tedious and very demanding for us to write down. Does that make sense? But in probability, I don't care what the individual winning tickets look like. I'm interested in how many total possibilities there are, right? Does that make sense? So what we'll do is, it's called a counting technique. We use a thing called permutations and combinations to allow us to get that total, okay, that we're able to make, okay? So as we talk about probability, and the reason I want to talk about probability is that it's actually the portion of math that is probably going to be most applicable to you and most influential to you outside of school. Okay? When you go to the doctor and you get medicine, they're giving you a particular medicine based on the probability that it's going to work for you. Does that make sense? Okay? Based on your symptoms, based on your conditions, your makeup, how big you are, that kind of thing. The medication and the amount of medication they give you, they're giving it to you because there's a high probability that it's going to work for you. Okay. If we talk about, you guys drive, pay for your own car insurance. Okay, who pays for their own car insurance? Okay, so let's say Austin and Jenna. Let's say that they have the exact same birthday. Let's say that they have the exact same every single piece of information that goes into filing for a insurance premium coverage. Okay, let's say that every qualifying condition that they have is equal. Okay, they're from the same. Let's say they're from the same residence. Let's say they're the same birthday. Let's say everything is identical about them, except for Austin's a male, Jenna's a female. Who is going to pay more money if they have the exact same everything, same car, same everything? Why Austin? But why? Okay, so probability-wise, young males are more likely to drive fast, more likely to make poor decisions, okay? Therefore, more likely to get in a wreck. And why is that important for an insurance company to say, he's going to pay more because he's more likely to get in a wreck? Why do you have to pay more? So you're more likely to get in a wreck. Well, okay, whatever, but why do I have to pay more than her? What is an insurance premium? Do we know what that means? Okay, so you guys pay your insurance monthly. Okay, so do you know how much you pay every month? Let's say you pay $100 a month. Okay, so he's insured, paying $100 a month. He pays that insurance premium for, let's say, 7 months. Okay, 7 months. He's giving up $700, right? Let's say he goes and he wrecks his brand new 2020. What do you drive? Honda. Okay. So let's say that car is $25,000. He has paid $700 in insurance to protect him in case he ruins his $25,000 car. He totals his $25,000 car. The insurance company is going to do what? They're going to replace it. Okay. They're going to replace it for what it's worth. Does that make sense? At the time of the accident. He only paid $700. They might pay a claim out that says, okay, we can give you, $22,000. Okay. Now he ends up on the short end, but is that better than him having to go buy a brand new car with no money? Does that make sense? Okay. But he pays more because they're more likely to make a claim on him. They're more likely to have to cough up that large amount of money on him than what they do for Jenna. Okay. Now, the way insurance works is that it's kind of it's a large pot that everybody pays into. Everybody's paying a premium in. Everybody's paying maybe that $100 or $120, $130 a month. And per your experience, per your past history, it changes. Okay. But we all throw into that pot. Okay. So the insurance company, they can pull out of that large quantities to replace a very few amount of claims. Does that make sense? Okay. So you guys are impacted by probability in that manner. Yes, Caitlin?
Well, I had a wreck the other day at Fort Lucky, and why do I have to pay for the ambulance and the other person?
Because it's your fault.
Well, it wasn't really my fault.
Huh?
It wasn't really my fault.
Oh, I just threw a spring at you. It is your fault. Were you cited? So it's your fault. So per the sheriff or police that came, they make the distinction because you got cited that was your fault. Therefore, the thought there is that if it wasn't for your fault, that person would be fine. So you should be.
She was trying to test me. Like I was going at another stop sign. She was like down there. I was like, okay, she's going slow enough. She pressed on her gas pedal and she fell on her road. She was going that fast. Yeah, she was going like 60 out of 25. But I couldn't prove that. That's not fair. And they said there was 7 injuries. Me and Maya were okay. The lady was walking around.
So the thing, so that an ambulance ride is expensive as well. So this is another thing that goes into when you buy car insurance. Your car insurance, you actually in your policy, you will have the opportunity to say, okay, I've got X amount of dollars allocated to the vehicle, but I've also got X amount of dollars allocated to things like taking care of somebody that I injured, or that their injury is a result of my actions. Because think about this: if somebody gets injured and it wasn't their fault, let's say I'm pulling out of the teacher lot and Julia just freaking T-bones me again, and I'm sitting there, I'm injured. Okay, if it weren't for her, I'd be fine. But now I'm injured. I gotta go to the doctor. I gotta go to the hospital, and my new car. So let's say I got broken ribs. I got to pay for that. Okay, is that fair to me that I got to now empty my bank account to pay for my injury that she caused? No. So your insurance policy will have that in it. Julia's insurance policy will have it in that if she injures me, then that insurance. So that's why it's illegal for people to drive cars without insurance. So what happens if a person drives without insurance, then they go to jail. Like that's the consequence for that. I don't know how that works. Like, yeah, but because there's no. So let's say that So if they don't have insurance, so basically what the purpose of insurance is if I get injured by you, then we're both covered. You're covered financially. I'm covered financially through your insurance. Now, if you don't have that insurance, I'm not covered financially, so I got to pay out of pocket to get fixed, right? That's not fair to me. And I don't have that money. So what do I do if I can't pay out of pocket because you harmed me? I sue you, right? But I sue you for money that you don't have because you didn't have insurance, so you probably don't have money to pay the lawsuit, right? Does that make sense? So what's the only consequence that comes down to? You go to jail. Yeah.
We were talking about this is like it's an act of help, make a mistake. And when she said, "You're being arrested, sir," and he just looked at her and he said, "Fine, that's really offensive." And it was so funny. And they just started putting him in the car. And he said, "People try to be so front." My video was sort of just cracking up. He's like, he thought this was.
Yeah.
They literally sent my entire packet about like a lawyer and
Yep. So I've told you guys remember the day that my wife called and I had to leave because she got in an accident, right? All right. So our insurance policy has like forgiveness. Okay, you've seen this on commercials where I think it's Progressive. We will forgive your first accident. Okay, which basically means that I don't have to pay anything. I have to pay my deductible, which means it's a small amount that I have to pay to get my car fixed, but the insurance picks up everything else. So she got in an accident in September, and then she got in an accident in November. Okay. So now, what's the insurance company telling me about her, or what are we telling the insurance company about her if she just gotten in 2 accidents? Yeah, she's got some driving concerns. Okay. So what's going to happen to my premium? It's going to go up. Why? She's shown a probability that is of getting in an accident that is higher than anybody else, right? So the likelihood that they're going to pay out a claim for her is higher. So now there's also insurance companies that you'll have, you know, those little, they're called OBD readers that are in your car. If your car's got like check engine light, they'll put a little device in there, plug it, and it'll read code and tell them what's wrong with your engine. Okay, so some insurance companies will have ones that you plug in that attach to a cell phone app and basically record your driving activity. And if you can go through like 90 days with showing like good driving activity, they will like forgive speeding tickets. So I've had speeding tickets, and that increases your insurance. Okay, so every speeding ticket you get, every traffic violation you get, you report to. Like I report to my insurance guy, so he's aware of it, and then he'll tell me, okay, well, your insurance just went up, but if you use this device for 90 days, instead of it going up maybe $90 in the year, it'll go up $20. Does that make sense? So they give you a little bit of a break there using those types of things, because you show then that you have been reformed. Like you've changed your driving habits in those 90 days. Yes. I think it does. Because I think the one that we had was actually you could get on the app and show your like routes and stuff like that.
Okay, so why should mine stop if it wasn't my fault?
It shouldn't.
No, it didn't. It wasn't my fault.
I don't know that. So another place that probability is used is stock market. Okay, the stock market is all about probability because I see a certain stock rising, and I'm going to take a chance on that, and the fact that I'm going to put my money in it and hope that it keeps rising. Okay, but what stock brokers will do, what your investment managers will do, is they'll ask you a series of questions that analyze your risk and how willing you are to lose money. And they'll say, okay, we're going to put you at an 80% risk, or a 70% risk or whatever. So I'm at like an 80% with my retirements. I'm at an 80% risk, which basically evaluates or crosses over to the idea that if I put $100,000 in it, I would be okay with losing like $30,000 tomorrow. Okay, so I could go $100,000 a day and play in the stock market, and it tanks, and now I lose $30,000 in one day. And I'm okay with that because the next day I might make $30,000. Does that make sense? Okay, so if I'm willing to lose $30,000, I'm also willing to make $30,000. And the way the stock market works is people that play the stock market today and get out tomorrow, or get in and out short term, they usually lose money. Okay, probability says that if you stay in the stock market over a long period of time, the gains that you realize will outweigh the losses. Okay, so the way insurance works is kind of like how casinos work. It's kind of reverse. Casinos, you could go to a casino and you can win $100,000 tomorrow, right? But what do most people do when they go to a casino? They lose. Okay, all the games are set up to be intriguing, to get some people to realize wins. And you might win in a weekend. You might win next weekend. You might win the following weekend. But that fourth weekend, you might lose twice as much that you won in the first 3 or 4. Okay, and that's the idea, is that they might have big singular payouts. They might have a $1 million payout, but they might also then have 1 million people that lose $2. Does that make sense? So if I have a $1 million payout, but I have 1 million people losing $2, did the casino just make $1 million? They did. Okay, so that's kind of how probability works in casinos. If my house in my neighborhood is very similar to one of my relatives, okay, who lives in Country Club Hills. The two ranches, very similar date of construction, similar square footage, all that kind of stuff. Okay, same type of materials. My home insurance is less than his. And the reason mine is less than his is because I live across from a fire hydrant, and he's nowhere close to a fire hydrant. Okay? Why would that be important? Yeah, so the higher probability of them putting out a fire at my house than at his house, okay? His insurance agent doesn't ask him about his diving board because he doesn't have a swimming pool. My insurance agent asked me about my diving board because what could happen, and it's if somebody's got a diving board, somebody could hurt themselves, right? So there's somebody, a visitor to my house is more likely to get injured at my house than they are at his house because there's a diving board at my house. Does that make sense? So those types of probabilities impact costs that you guys are going to realize at some point in your life. So that's kind of where I want to take some of this stuff with probability, but I want you guys to see that it's something that impacts you. Okay. Just going through some of these notes. It says sample space. Sample space to set up all possible outcomes in an experiment or a random trial in a probability scenario. Okay, so when I talk about an experiment, it's like if I were to roll this dice, how many different things can come up, face up? A 1 can come up, a 2 can come up, a 3, a 4, a 5, or 6, right? There are 6 total outcomes. Does that make sense? So the sample space size here would be 6. Okay? We can easily count those on a dice, right? Okay. What if I ask you, I'm going to roll these 2 dice. Okay? And now I'm going to ask you, what are the different outcomes that could come there? Well, I could have a 1 and a 1, right? I could have a 1 and a 2. 2 here. I could have a 1 and a 3. I could have a 1 and a 4, right? I could have a 1 and a 5. I could have 1 and a 6. Does that make sense? So you have 1 paired with 1, 2, 3, 4, 5, 6. So that would be 6, correct? 6 outcomes. Could I have a 2 on my first dice paired with a 1 on my second? Could I have a 2 paired with a 2? Could I have a 2 paired with a 3? A 2 paired with a 4? A 2 paired with a 5? And a 2 paired with a 6, right? So we're going to have a 2 and a 1 and a 2 and a 3 and a 4 and a 5 and a 6. That's 6 more, right? So I have 6, 6 more, and now let's go to 3. Can I have 3 paired with a 1? 3 paired with 2? 3 paired with 3? And that would eventually give me 6 more outcomes, right? Does that make sense to everybody? How many outcomes would I have total if I keep doing that? I would have 36, okay? 36 different outcomes that could happen when I roll this dice. So when I ask you, what's the probability of rolling double ones, okay? There's only one of those 36 that shows up. So 1 out of 36 would be that probability. But in order to analyze that probability, I need to know what my possible outcomes look like, the possible things that can happen. And that's the sample space. And that's what we're trying to get into today, is that 36 size sample space is hard to realize. It's hard to come up with. If I have 3 dice, now that sample space went from 36 things to 216. Okay? You wouldn't want to have to list those 216 things like we just did with the 36 outcomes. So these techniques that we're going to talk about here, these counting techniques are going to allow us to get that denominator in our probability much quicker than having to draw out sample spaces. Okay, so it's counting techniques. Okay, here are we're going to talk about 3 counting techniques. There are more, but these are the 3 most common. It says combinations, permutations. Did you hear that, Noah? Permutations. And fundamental counting principle. When you guys know the fundamental, have you guys heard the question back in like 6th, 7th, 8th grade where it says Sally has 3 pairs of pants, 4 shirts, and 5 hats? How many different outfits can she make? You guys remember those? Okay. So we'll talk about that. And determine how many different outfits you can take or make is the fundamental counting principle. Okay. But it says all of these are ways that you're trying to determine the sample space. Okay. And they can also help us determine the numerator of probability as well in certain situations. All right, so the fundamental counting principle, what it is, it says it describes the method of using multiplication to count the number of ways certain things can happen. And then I give you down here the actual definition in math terms. Okay, so this fundamental counting principle says if event M can occur lowercase m ways, and event N can occur in lowercase n ways, then the event m followed by event n can occur in m times n ways. Okay? So, how many different ways can this dice occur? How many different outcomes can I have if I roll this dice? 6. How many different ways can this one? 6. So if I roll this one, I get 6 chances. 6 different things could come up. Roll that one, 6 different ways come up, right? 6 times 6 tells me I've got 36. Thank you. 36 different things that could come up. Does that make sense? Okay. Let's do this, and I'll show you a way of doing this with what we call a tree diagram. And why? So if this person has 2 pairs of pants, 4 pairs of socks, and 2 shirts, there are 2 times 2 times 4, which is 16, right? 16 different outfits that can be made. And the tree diagram demonstrates that. So what we do here is we start with one of these. It doesn't matter which one we start with, so I'm going to start with the pants. Okay, if we start with pants, there are 2 options for pants, right? So if I wear pants number 1, okay, I could then wear shirt number 1 or shirt number 2, right? If I wore pants number 2, I could have paired that with shirt 1 or shirt 2, right? Does that make sense?
Pardon interruption. This is just a quick announcement from Mr. Pritchard's 5th period class. You are going to report to the library today and eat lunch. So for 5th period, report immediately to the library, and then you will eat lunch. Again, that's Mr. Pritchard's 5th period class. Thank you.
Okay, so let's say I wore pants 1, shirts 1, and now I go socks 1, 2, 3, 4. So those are my options for socks, right? Maybe I should have made my picture a little bit bigger here, but now if I go pants 1, shirt 2, can I go socks 1, 2, 3, 4 again? Does that make sense? Okay. Now if I went, see if I can move these. All right, so if I went with pants 2, shirt 1, I could have gone socks 1. For whatever reason, it's not letting me write that the way I want to in Word. All right, so we got pants, shirts, and socks. So we went pants 1, pants 2, shirt 1, shirt 2, shirt 1, shirt 2. So if we go pants 1, shirt 1, socks could go 1, 2, 3, 4. And then these could go 1, 2, 3, 4, right? These could go 1, 2, 3, 4. And then these could go 1, 2, 3, 4. I know my tree is kind of, it's not, I didn't give myself enough room, but what we can see here, hopefully, is that we could have an outfit that goes 1, 1, 1. 1, 1, 1. Does that make sense? I could have an outfit that goes 1, 1, and 2. I could have an outfit that goes 1, 1, 3. And one that goes 1, 1, 4. Okay? So pants 1, shirt 1, socks 1, 2, 3, and 4. How many different outfits could be made there? That's 4 outfits, right? Okay. I can go pants 1, shirt 2, socks 1. Pants 1, shirt 2, sock 2. So I go that, right? 1, 2, and then 1, 2, 3, 4. Okay? Is everybody okay with that? How many outcomes are there? 4, right? So here are 4 outcomes. Here are 4 outcomes. Now, let's start with pants 2. Go shirt 1, socks 1. Pants 2, shirt 1, sock 2. Pants 2, shirt 1, sock 3. Pants 2, shirt 1, sock 4. 4 more outcomes, right? But I could also go pants 2, shirt 2, sock 1. Pants 2, shirt 2, sock 2. Pants 2, shirt 2, sock 3. Shirt 2, or pants 2, shirt 2, sock 4. How many outcomes there? 4, right? How many total outcomes do we have? How many different outfits have we created here? 16, right? Okay, 16 different orders, okay, which is the same thing as 2 pants times 2 shirts times 4 socks. That gives me 16 as well. Now, ultimately, I'm not really too interested in what each of these individual outfits look like. I'm just interested in how many there are. Does that make sense? Okay, so much easier to just take 2 times 4 to get the 16 for our sample space. Is that all right with everybody? And then the idea is, okay, well, what if this person has 5 pairs of pants, 13 shirts, 5 hats, 12 pairs of shoes, and 3 belts? How many different outfits can they make? Now, you would not want to do the tree that we just did. You would just want to take all those numbers and multiply them together and get yourself probably the thousands of outfits that could be created there. Okay? That's assuming that outfits don't have to have like style or anything like that. Yeah, kind of like me. I'm all right with that. All right, so one of the things that we see is license plates. Phone numbers are another thing that this happens with. Okay, if I were to ask you, guess my childhood phone number. Okay. Nope. My childhood phone number never had 419 on it. Okay. Does anybody know? Never had 567. Nope. Just had the area, or not the area code. It had so I lived in Cairo, so it was 641. That was it. Okay. So my phone number was 7 digits. Your guys' phone numbers are all 10 digits. Okay. And we'll talk about why. Okay. Let's think about. Let's use this example here, and then maybe tomorrow we'll talk about the phone numbers. Here it says in 2004, Maryland license plates were composed of 3 letters followed by 3 digits. So the 1912 license plates were simply 4 digits. It says how many more license plates were available in 2004 than 1912? Okay, so let's go to the 1912 scenario. We had 4 digits that could be placed on a license plate. Okay, so what I like to do with this, I'm going to say 1912, and I'm going to just create 4 spots for my license plate number. Okay, now if I'm talking about digits, how many digits are there? 10. But is 10 one of them? So it's 0 through 9, right? So if I count 0 through 9, there's 10 things that can go there, okay? So somebody's license plate in 1912 could have been, it could be 0, 0, 0, 0. Does that make sense? It could be, it could be 1, 0, 0, 0. Okay, so if I'm trying to list all the different license plates that could be made, that would be hard. Okay, but you just told me 10 numbers could go there in that first spot, right? Okay, and we can have 0, 0, 0, 0 as a license plate. Okay, so I got 10 numbers could go there. So then the same 10 numbers could go here, right? So then the same 10 numbers could go there, and the same 10 numbers could go there. And this is the fundamental counting principle. Instead of shirts and shoes and hats and that kind of thing, it's how many objects go here, how many go here, how many go here, and that's going to give me 10,000 license plates, right? Why would I need more than 10,000 license plates? There's more than 10,000 cars, right? 1912, there wasn't in Maryland, okay? So more cars, I need now a new system. I need a new system to create license plates, right? So what do? They add letters. Okay, so if I have 3 letters here, how many different letters can go here? 26. How many can go here? 26. And then how many can go here? 26, right? So now that's nice. That's more than 10 times 10 times 10 maybe, or 10 times 10 times 10 times 10. But that's still not more than the cars that we have on the road. So then we say, well, let's put 3 digits on it. And we multiply all that together, and that gives you like over 176 million or something like that. Okay? Which, are we going to have more than 176 million cars? No. Okay. You ever call somebody? Actually, this probably never happened to you. You guys understand that, like, when somebody passes away or somebody gets rid of a cell phone, that number goes dead for a while. Does that make sense? Okay. But eventually that number gets reused, right? Gets put back into the system. And the reason for that is that the number of phone numbers that can be created and the number of phone lines that are available do not match. So they have to reuse old cell phone numbers. We'll talk about that tomorrow.